Let's go to page 490 and let's start with number 1. You have the sigma of n plus 2 and you want to go n equal to 1 through 6. So go and work it out. So when n equal to 1, you're going to get 1 plus 2. When n equal to 2, again, that would be a second term. So just do that for 1, 2, 3, 4, 5, 6. Okay. So again, this is your formula. You just substitute for 1, 2, 3, 4, 5, 6, and then you work it out. So this is equal to 3 plus 4 plus 5 plus 6 plus 7 plus 8. Okay, so that's it for number 1. Now don't add all this together. They just want you to expand. So that's what the expansion is. Okay, number 3. You have sigma of 2 to the t and t equal to 1 to 5. Okay, so this one is very easy. You don't even have to do that. You can just substitute. So it could be 2 to the 1 plus 2 to the 2 plus 2 to the 3 plus 2 to the 4 plus 2 to the 5, right? So just 1, 2, 3, 4, 5. So the variable part is the part that's going to change. And then you can go and work it out. So this is equal to 2 plus 4 plus 8 plus 16 plus 32. Okay. Now, you don't have to box the answer because the answer is kind of long. Okay. Okay, let's go to number 5. You have sigma of 3 to the negative n. And you want the n equal to 2 through infinity. So for this one, you just go and do the, maybe about a few in the beginning. So this is going to be 3 to the negative 2, right? The first one is 2, plus 3 to the negative 3, plus 3 to the negative 4, plus dot, 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 dot. And it's infinity, so it goes on forever. So next, you have to go and flip this over. So this is 1 over 3 squared, plus 1 over 3 cubed, plus dot, 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 dot. Okay, 1 over 3 to the 4. So this is equal to 1 over 9 plus 1 over 27 plus 1 over 81 plus dot, 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 dot. Okay, and so that's number 5. Okay, let's go to number 7. Number 7, you have a sigma of absolute value of 4 minus k, and you want a k equal to 2 to the 7. Okay, so first one would be absolute value of 4 minus 2, and you're going to get 4 minus 3, and you're going to get 4 minus 4, 4 minus 5, 4 minus 6, and 4 minus 7. You can just substitute, right? It's 2, so it'll be 2, 3, 4, 5, 6, 7. Then you go and work it out. I can do it step by step. So it'll be absolute value of 2, absolute value of 1, absolute value of 0, absolute value of negative 1, absolute value of negative 2, absolute value of negative 3. And then from here, this becomes 2 plus 1 plus 0 plus 1 plus 2 plus 3. Okay, okay, let's go to number 9. So number 9 is going backward. Okay, over here they give you the sigma notation and you expand. Over here they're going to give you the series and you have to make into sigma notation. So you got 5 plus 10 plus 15 plus dot, 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 plus 500. Again, there are many ways you can do this. Okay, so the first way is go and do it by formula. So you have to figure if it's arithmetic or geometric. So this is arithmetic by plussing 5. Okay. So your arithmetic formula would be t of n equal to t1 plus it would be t of n will equal to t1 plus t times n minus 1. Okay, so you can just substitute some of the numbers in here to figure out what the final n is. Okay. So your sigma notation, your formula is going to be this over here, but you got to substitute to find the d, the n. Okay, you have to figure out what n is. So n equal to 1, but you need to figure out what's the last one. So this is n is like the first, second, third, fourth. Okay, so this is n equal to 1 because this is the first term, this is the second, this is the third. Again, this 3 means the third term, but you don't know what this n is. So you need to figure out what this n is so you can put over here. And again, whatever you need to do is you use this formula. So 500 equal to 5 plus 5 times n minus 1. So you need to find what n is. Since you're looking for n for this number, so you have to use this number over here. Okay, so you can go and work it out. You can go and work it out. Again, many ways you can do this. So you can multiply. So simplify, so you got 500 equal to 5n, divide by 5, divide by 5, so n equal to 100. Okay, so you can put 100 over here, and the formula would be, this is your formula right over here. This is for each one. So it'd be 5 plus 5 times n minus 1. Okay, because t of n, whatever you have over here, that goes over here. Okay. And again, the n is going to vary from 1 through 100. So this is one of the ways to do it. Okay. Now there are many ways to do this. Another way is to do it by pattern. So if you have 5 plus 10 plus 15 plus plus 500. Okay. So this is n equal to 1, n equal to 2, n equal to 3. And when you write this, you can match up. Notice that you times it by 5. This is 5 times that, 5 times that. So right away from here you can see n equal to 100. And so from here you can see that n equal to 1 through 100, and it'll be 5n. Okay? So 5 times whatever n is will give you the number. And again, n's are going to vary. Okay? Like this one, if you were to simplify this, you get that, the same thing. Okay? So you can do it either way. Okay, let's go to 11. Okay, you got 1 to the 4 plus 2 to the 4 plus 3 to the 4 plus 10 to the 4. Now this is neater, so you have to do it by pattern. Now if you're going to do it by pattern, what you do is you look for the common element. Okay, notice always, so you're going to have a number to the 4. Okay, so when something stay the same, the constant, you write it down. The things that vary would be your variable. Okay? And notice vary from 1 through 10, so n will equal to 1 through 10. Okay? Again, the part that change is your variable. And it's going to vary from 1 through 10, so you go from 1 through 10. Okay? And that's it for number 11. Okay, 13, you have 2 plus 2 times 5 plus 2 times 5 to the 2 plus 2 times 5 to the 3 plus plus 2 times 5 to the 12. Now this one is geometric. You can do it by formula, but this one is easy if you do it by pattern. Okay? You can notice every one of these have 2, right? So it'll be 2 times something. Okay? Now notice that there's an exponent. The part, notice there's a 5, 5, 5. This one does not have 5, but because it's 2 times 5 to the 0 power. That's what this one is. Okay? So again, there's a 5 to something, so it'll be 5. Again, anything that you have same, you write it down. The part that varies, the part that changes is your variable. So the variable goes up here, right? Because that's where exponent is varying. And so, and ask yourself the question, okay, what does it vary to? Now, from what to what? Well, you start from 0 to 12, right? So n equal to 0 to 12. Okay, and that's your answer right over here. Okay, let's go to 15. Okay, you got 1 plus 3 plus 5 plus 7 plus plus 99. Okay, so this one, you can see that this is arithmetic series, so it'll be d equal to 2, right? So this d equal to plus 2. Okay, so formula, so n equal to 1. So again, you want to find out, so this is n equal to 1, n equal to 2, n equal to 3, right? This is the third term, fourth term. Now, you don't know what this one is. So whenever you're going to figure out something, you got to use the formula, right? The general formula. So T of n equal to T1 plus D times n minus 1. Now for the n for this one, you have to use this number over here. So it will be 99 equal to 1 plus the D is 2, n minus 1. Okay. And from here you can go and work it out. So 99 equal to 1 plus 2n minus 2. And you can go ahead and plus 2 minus 1. So n always plus 1, right? Right? Plus 2 minus 1 give you net of plus 1. So 2n will equal to 100. So n equal to 50. So from here we can see n equal to 50. So n is going to go from 1 through 50. Okay? And again, whatever the formula is this part. This part is what goes in here. So that is this part right over here. So it will be 1 plus 2 times n minus 1. Okay. Now if you want to simplify these, you may. So if you can leave it like that, or if you simplify, you end up with 1 plus 2n minus 2. And so this would become 2n minus 1. Okay. So that would be the answer. So either one is fine. Okay, let's go to 17. So again, I'm switching between different methods. So you can use whatever method you feel comfortable with. So you can do it by pattern, look for pattern, or you can do it by formula. Now this one again, you can do it by formula, which is geometric. Okay, so this would be times by 2, times by 2. Right? So this is geometric. So for geometric, your formula would be T of n equal to T1 times R to the n minus 1. Okay. And so T1 would be 2, and R is 2 to the n minus 1. And so it's going to go from n equal to 1 through this one, but you don't know what this one is. So you have to use this formula again, right? So you got 120. So if you're going to figure out what n is equal to over here, then you have to use this number for the Tn. So 128 equal to 2, that's T1, times 2 to the n minus 1. So divide both sides by 2 to get rid of this number over here. So 64 equal to 2 to the n minus 1. Well, to solve this, you have to convert this into base 2, right? So it would be 2 to the 6 equal to 2 to the n minus 1. So by matching, 6 equal to n minus 1. So plus 1 on both sides. So n equal to 7. So this one is a 7th term. So n equal to 7 means this is a 7th term. So go to 7. And that's it for this one. Okay. Now another way of doing this problem, okay, a different way of doing this problem is by doing pattern. Okay. By realizing that this is 2 to the 1, and this is 2 to the 2, this is 2 to the 3, this is 2 to the 4, and this is 2 to the 7. Okay, 128, right? It's 2 to the 7th power. You can do this. 264, 232, 216, 28, 24, 22, right? So you can count it. There's 7 of it, right? And then what you want to do is write down the n. So this is for n equal to 1, n equal to 2, right? First term, second term, n equal to 3, n equal to 4, and so by that you can see that they all match. So this is n equal to 7. So you can see that this is equal to 2 to the n power. Right? Again, these are all the 2, so 2 stay the same. The part that's vary, that's the variable, and n is going to go from 1 through 7. Okay, so this is another way of doing it. Okay. So you can make a comparison between this and that. They're the same thing. If you simplify these, you get that. Okay, so either way. So you can have different method of doing it. So you got to figure out what works for you and what you feel more comfortable with. Okay, let's go to 19. Okay, you got 1/2 plus 1/3 plus 1/4 plus 1/5 plus dot 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 dot. So this is the infinite series. Okay, so instead of start, you don't always have to start with 1. You can start with any number. So if I make n equal to 2, and n equal to 3, n equal to 4, n equal to 5, then you can see that this is 1/n, and n is going to go from 2 to infinity. Okay. Now, if you use different n, if you always start with 1, okay, let's say if you so if you take n equal to 1, so if you make this the first term, second term, so you have to, in this case, the relationship between this and that is that this is n plus 1. Notice that this is n plus 1 will give you that, n plus 1 give you that, n plus 1 give you that. So in this case, this you're going to get n plus 1 down here, and you're going to get n equal to 1 through infinity. Okay, so this is another option. So again, they are the same. Okay, so you can do either way. So you can watch. So you don't always have to start with 1. Depends on what you start out, and so your index will be different. Okay, let's go to 21. Yeah, -9 plus 3 minus 1 plus 1/3 plus dot 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 dot. Okay, so this one r is going to be equal to -1/3. Right? You times by -1/3 to get the next term. So that's your r. So r equal to -1/3. So this is geometric. Okay, so geometric and it's infinite series. So right away, this one I'm going to do 1 through infinity. And the formula would be t of n equal to t1 times r to the n minus 1. Right, again, always write down your formula and then you start to substitute. Okay, so t of n equal to -9 times -1/3 to the n minus 1. And that's what you have that you can put in here. It would be -9 times -1/3 to the n minus 1. Okay, and that's the answer. Again, you can simplify these, okay, if you want to, and you know, but it's unnecessary. You can just leave it like that. Okay, 23. Yeah, 6 plus 12 plus 24 plus 48. Okay, so this is geometric. Okay, so this is geometric with r equal to 2. Right? You have to times by 2, times by 2, times by 2. So r equal to 2. So this is geometric. And there are 4 terms, 1, 2, 3, 4, so this one is easy, so n equal to 1 through 4. And the formula would be, again, t of n equal to t1 times r to the n minus 1. So t of n, and the reason you don't substitute this into here because you're looking for the equation for all of them, not just this one, so you don't substitute into here. So it would be 6 times 2 to the n minus 1. And that's what you're putting it, so it would be 6 times 2 to the n minus 1. Okay, let's go to 25. Okay, number 25, you have 1 plus 1/4 plus 1/9 plus 1/16 plus dot dot dot. So you got to recognize that these are the perfect squares. So what you want to do is go and make this into 1/1 plus 1/2 square plus 1/3 square plus 1/4 square, and make this into 1 square. Okay, and from here you can see the pattern, right? So again, the top, again you do it by parts. So on the top it's always 1. The base, it varies. So when things change, that's your variable. Okay, 1 square. Okay, and look at the exponent. Exponent is always square, so it would be n square. Okay, and so this would be n equal to 1 through infinity. Okay, and that's it for 25. Okay, let's go to 27. Okay, 27, you have to read the description and write down your series first. It says the series consists of the positive 3 integer divisible by 5. Okay, so 3-digit integer divisible by 5. So be 100 plus 105, 110, 115 plus dot 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 dot. And the largest 3-digit integer is 995. Okay. So again, there are different ways you can do this kind of problem. Okay, one is by notice the pattern. So this is, notice all is a multiple of 5, right? So this is 5 times 20. This is 5 times 21. This would be 5 times 22. And then dot dot dot. And this would be 5 times, you can get your calculator and you can divide. So 995 divided by 5 equal to times 199. Okay. So again, from here, you can see that it's going to be 5 times n. Right? Again, 5 is same. The constant, you write it down. The number, when it's varied, it becomes variable. Okay. So the variable part is it goes from 20 through 199. So it means n equal to 20 through 199. Okay. And so that is one answer. Okay. Another possible way to do these is by just doing by formula. So you got 100 plus 105 plus 110 plus dot 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 plus 995. So recognize that this is arithmetic, right? So it's plus 5 plus 5. Okay, so when it's arithmetic, right? So you got t of n equal to t1 plus d times n minus 1. Okay, so you want to go from n through n equal to, so this is n equal to 1, and you need to figure out what this one is. So use this formula. So 995 equal to 100 plus 5 times n minus 1. And before you go any further, this part is your formula over here. So it would be 100 plus 5 times n minus 1. Okay, so this is for every term. But the one you're looking for, when you try to figure out what's the n for this number, you use this number, right? Again, they have to match. So this n is for this number. And so you want to find out what is the final number for the n. Okay, so you can work it out. So 995 equal to 100 plus 5n minus 5. And so you got 995 equal to 5n plus 95. So you got 900 equal to 5n divided by 5. So n equal to 180. Okay, and that's it. Now notice they're basically the shifting of each other. Now you can work this out if you want to. You can simplify that. So if you work it out, you get 100 plus 5n minus 5. You get 5n plus 95. So another option is, so this is one option, that's one option. Another option is if you simplify, you get 5n plus 95. Okay, so again, there are many different options. Okay. Now notice the shifting. Notice over here, this is 1, this is 20. Notice it's got shifted by 19. So if you shift this by 19, you get 199. Okay, so this is just kind of shifting. That's all you're doing. The shifting of index. So again, there are different options. Depends on which way you do it. The answer is going to be varied. Okay, but if you expand each one of these, you should end up with exactly identical series. Okay, let's go to number 29. It says an infinite series, an infinite geometric series would start with first term 1 and a common ratio of 1/4. Okay. So you just keep multiplying. So it tells you that r equal to 4, 1/4. Okay, so you can sum. Okay, so geometric. So t of n equal to t1 times r to the n minus 1. And this is the infinite series, so right away you know that n equal to 1 through infinity, right? So when you substitute t of n equal to t1, r is 1/4 to the n minus 1. Now 1 times whatever, it's just going to be whatever, right? So it would be just that part. So it would be just 1 over 4 to the n minus 1. Okay, and that's it for number 29.